Okay, so the review is all about logarithms and then rewriting logs to exponentials and rewriting exponentials to logs and solving. Write the equation 2 to the 11th equals 2048 in logarithmic form. That would be log base 2 of 2048 is equal to 11. Remember, it's the base raised to this exponent makes this one. So when you write it as a log, it looks pretty much the same every single time. And you can always count on that pattern being there. Write the equation log base 4 of 16 equals 2 in exponential form. That would be 4 squared equals 16, which is true. On number 3, log base 6 of 1 over 216, I would expect you'd be able to do this one without the calculator, but if you use the calculator, it comes up to -3. The negative makes it flip. 6 to the third is 216. On number 4, log base 2 is 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. This is 4. Write the expression as a single logarithm. The first thing I'm going to do is take these coefficients and make them into exponents. So that would be the log base b of v to the 6th plus the log base b of q to the 7th. I haven't changed anything except the location and orientation of those numbers. I made the coefficients, the 6 and the 7, into exponents on the variables. So instead of 6 log base b of v, it's log base b of v to the 6th power. So then, this is adding. So I'm going to multiply them. They are separate variables. So I can't just be like, oh, I'm going to add the exponents. That doesn't work unless it's the exact same variable. So this becomes the log base b of v to the 6th, q to the 7th. Number 6, I'm subtracting, so I divide them. That's log base 7 of 32 over 8. 32 divided by 8 is 4, so this is the log base 7 of 4. When I go to expand them, 12 is being multiplied by d squared. So I'm going to add them. This is the log base 8 of 12 plus. Now, I'm also not going to leave it as d squared. I'm going to take that exponent and make it into a coefficient. 2 log base 8 of d. On this one, that's a whole lot to expand, but it'd basically be the log of 3 plus 2 times the log of x plus 6 times the log of y minus 5 times the log of z. Okay, the z is on the bottom, it's what's being subtracted. All the rest of these are on the top, they're being added together, and any exponent on any one of them should be made into a coefficient. This thing's not perfectly in focus. On number 8, this one was on the quiz. When you have the square root, you can't just treat it as a square root. You have to make it into an exponent. So when we were working on square roots and exponents, the exponent that's the same thing as a square root is 1/2. So on number 8, I'm going to do this one in 2 steps. This is the log base 7 of 33 to the 1/2 power minus the log base 7 of 24 to the 1/2 power. Now that's not how it looked on our quiz because they did not leave it to the 1/2 power. They took those exponents and made them into coefficients. So it was 1/2 log base 7 of 33 minus 1/2 log base 7 of 24. On one like this where it's all numbers, chances are on the test, at least on the questions that are multiple choice, I think there's like 3 questions that aren't. You could just type this into the calculator, granted that we get them back in time. you could just type this into the calculator and see what number pops up on the original, and then make sure that the number that pops up on the answer is one that matches that. If we don't have our calculators back, number one, I'll be surprised. But if we don't have the calculators back, just make sure you bring a Chromebook. You'll be able to use Desmos. We'll do it that way. Okay. Number 9, use the properties of logarithms to evaluate 2 log base 2 of 64 plus the log base 2 of 2. You can use the laws of logarithms or the properties of logarithms, but you don't really have to. Evaluate means you're figuring out a number. So what I'm going to do is just do the log base 2 of 64. 2 to the first power is 2, times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. The log base 2 of 64 is 6. So this is 2 times 6 plus log base 2 of 2. 2 to the first power is 2. That's 1. 2 times 6 is 12 plus 1 is 13. I don't have a calculator with me, so I will finish the rest of these out on there, but I'm going to get you started on it. On this one, it's exponential. I'm going to rewrite it as a log. So I would rewrite it as log base 7 of 43 is equal to 7x, because again, this base raised to this power makes this. Okay? I would type log base 7 of 43 into the calculator, and then I would divide it by 7. That'll give me my answer for x. On this one, same thing. Log base 3 of 24 is equal to x. Is that supposed to be plus or minus? Minus 1. Because 3 raised to the x minus 1 equals 24. They told us that. So the log base 3 of 24 is going to be between 2 and 3. And then I'm going to add 1 to it to get my answer. On this one, there's no base to the log. It's a logarithm. I'm going to rewrite it as an exponent. There's no base to the log. So this is going to be 10. 10 to the first power is equal to 9x plus 4. Well, 10 to the first power is just 10. I subtract 4, that's 6 equals 9x. Divide by 9, x is 2/3. On this one with the 2 in the front, I could make it into, someone would grab the door. I could make this 2 into an exponent. It'd be a waste of my time. I'm going to divide it out. I divide by 2, I divide by 2. That's the log of x equals -2. This is a base 10. So now I turn it exponential. 10 to the -2 is equal to x. If it's 10 to the -2, I'm going to flip it over the fraction line. That'd be 1 over 10. And then I'm going to square it. X is going to be equal to 1 over 100. The log of 2x minus the log of 16 is equal to 0. That would be the log of 2x over 16 is equal to 0, which means the log of x over 8 is equal to 0. So 10 to the 0 power equals x over 8. 10 to the 0 power is 1. So 1 is equal to x over 8. I multiply by 8. 8 times 1 is 8. X is 8. Makes sense too. The log of 16 minus the log of 16 should equal 0. On this one, same kind of thing. We're subtracting. It turns into a fraction. That's the log of 7x plus 1 over x minus 2 is equal to a 1. I'm going to add 1 to both sides to get that 1 over there so I can put my logs together. So that's 7x plus 1 over x minus 2 is equal to 10 to the first power, which is just 10. I multiply both sides by x minus 2 to get rid of my fraction. So I end up with 7x plus 1 is equal to 10x minus 20. I add 20 to both sides. I subtract 7x from both sides. And I get 3x is equal to 21. So x is 7 on that one. On the graphing part, there is a graphing portion on the test. It's not necessarily, I don't think it's a multiple choice section. Okay? It's just you graph, and you don't have to actually sketch the graph, I don't think, but you have to list what is the domain and what's the vertical asymptote. On this one right here, the domain, x is greater than 3/2. The vertical asymptote is at 3/2. It's this number. None of the rest of that stuff really matters. On this one, x is greater than a -1/4. My vertical asymptote is -1/4. On this one, x is greater than 2. My vertical asymptote is 2. On this one, x is greater than 3, and my vertical asymptote is 3. Okay? It's the h value that you have to pay attention to. On the back side, write the expression as a single natural logarithm. The natural logs work the same way as the regular ones. We're adding, so we're going to multiply, and we have a coefficient that becomes an exponent. That would be the natural log of 5 squared, which is 25, and then the 6 is going to come over here. That's x to the 6th. 3 natural log of y minus 3 natural log of x. That's the natural log of y to the 3rd over x to the 3rd. The sales of lawnmowers T years after the particular model is introduced is given by the function y equals 5,500 natural log and 9t plus 4, where y is the number of mowers sold. How many mowers will be sold 3 years after a model is introduced? Graph it and look at the value of 3. It's going to be 5,500 times the natural log of 31, which probably around 30,000. Okay, I'm not real sure. I'd have to put it in on the calculator because that's, when you solve this, if it's a log, you rewrite it as an exponent in base e. Okay, so this is e to the 3rd equals 4x plus 3. We'll end up with what x equals. E is not a variable. So again, use the spot on your calculator, the number on your calculator that is e raised to the x. That'll get you in the right spot here. Again, I'll get the number up here later, but you're just rewriting it. This would be the natural log of 2x equals 1. So e to the 1st power is equal to 2x. You're going to take e to the 1st power, you're going to divide it by 2. And then on number 21, 8e to the 2x plus 8 equals 21. You subtract 8, that's 8e to the 2x is equal to 21 minus 8 would be 13. Divide by 8, that's e raised to the 2x is equal to 13 over 8. So that's the natural log of 13 over 8 is equal to 2x. You have to remember the natural log is the same thing as log base e. Okay? The natural log is log base e. I believe that's one of the questions on the test even, is what is the natural log, or what's another way to write natural log, and it's log base e. It means the same thing. Applications of log to compound interest. Most of these we can do already. Like we did these back when we were working exponentials. It's not a big deal. Convert the percent to a decimal, add 1 to it if it's growth rate, and then multiply it out. Here's the thing you need to know. There's 2 questions on the test that have to deal with compounding continuously. On this review, it's 25 and 29. We're not doing those on the test. That means on the test, there are 20 questions. There are 2 of them that you will not answer at all. Okay, leave them blank. Don't try to get them. It's not going to be bonus. We're not working anything out like that. Okay, it's just 10 points basically for putting your name on it and skipping the ones you're supposed to skip. Real quick, on number 23, if it says compounded quarterly, you take your rate, 6.5%, 0.065, you divide that by 4 because it's being compounded 4 times in a year. You'll take your number of years and multiply that by 4. So it's going to be your $12,000 times 0.065 is divided by 4. You'll close that up and you'll raise it to the 12th power because it's 4 times a year in 3 years. All right? If you're not sure how to do it, work it out like you would annually and then pick the one that goes up a little bit from that because compounding quarterly is going to yield you just a tiny bit more money than compounding annually. In interest of not making this video 45 minutes because it's already at 16, I'm just going to stop here. I will post like the answers to this. Again, tomorrow you take the U.S. history end of course, most of you. So we won't take the test tomorrow. We'll take the test Thursday.